Welcome back. So this is the next problem set. Maybe you've already done this, but if you haven't, in order to do these problems, which are also in your packet from class on Friday, you should try sitting down in a quiet space and doing a time trial first. You can pause the video if you want to do that now. After you've done the time trial, you're going to want to take a moment to think about your strategy, but then also stop and solve any questions that you didn't get to. It's good to do the time practice, but it's also important that you do understand these questions and work out as many of them as you can, even if you can't do it in 15 minutes. From there, you're going to input your answers, and that's where we'll start this video. So if you need to do any steps 1, 2, or 3, just pause, and then when you're ready, we'll get going. Here's questions 1 and 2. Question 4 on the original video, on the original packet, had a typo. Please look at these new answer choices. They will be different than the ones that you have in front of you. And I actually made a mistake. Question 7 is not a question that you know how to do. So ignore this question altogether. Perfect, so let's get going with some answers. Here's question 1. The correct answer was A, and you just needed to really remember about the notation. This is the notation that you actually learned about on your midterm, and the 2 little tick marks represent the second derivative, which just means that you take the derivative 2 times. So here's the original function. I've rewritten it to show that it's really cosine squared. And so I use a chain rule to take the derivative the first time. Outside function is something squared, so the 2 comes in front, there's the inside function, and then I multiply it times the derivative of the inside function. That's the normal derivative. The second derivative is the derivative of the derivative. To take the derivative of this, I need to use a product rule. So here's my product rule, and then actually there was a way to simplify that just to write cosine times cosine is cosine squared and sine times sine is sine squared. After that, I just need to plug in pi, and cosine of pi is -1, sine of pi is 0, and so I end up with -2 as my answer. That was question 1. Question 2 was a really simple chain rule. The correct answer was D, and here's what the chain rule looks like. It's actually a chain rule with 2 layers. So originally the outside function was the ln function, and we can take the derivative of that, but inside of that is another nested function. ln of 1 minus x is itself a chain. So I came down and did the chain rule for that in order to get the derivative of the inside function. Then I use my derivative of the outside, plug in the inside, and multiply times the derivative of the inside to put it all back together in the chain rule. And this is the simplified version. Make sure that you didn't multiply 1 minus x times 1 minus x. This is a normal binomial 1 minus x. This is the inside of the ln function. They cannot be combined because of the ln function. And in the final answer, the order was flipped, but that's okay, it's just multiplication. If you want to take a look at all of the work here, I'll try and zoom out so you can see it. And question 3. Question 3 was just a really simple product rule. It looks like I didn't mark the answer here, but it should be D. And if you want to see my product rule, there was a chain rule inside of it just to do the little 2x thing. Question number 4 is the one where I had you change the answers because there was a typo. Looking at the actual math, it's telling you to evaluate a limit at 8. And actually, if you look at this, if you imagine taking the limit as x approaches 8 of this rational function, you can just plug in 8. And this is maybe kind of like the test trying to trick you, because your instinct is going to be to factor and to simplify or to use the biggest term rule. Well, the biggest term rule is only when you have a limit approaching infinity, not 8. And you only have to really factor or simplify if you have a discontinuity, as in if the denominator equals 0. But we can just plug in 8 and just get a numerical answer, which turns out to be 1/2. And you can check out my multiplication here, if you need to look at it. Question 5 is one of my favorites. You've heard me talk about it before. This is also an example of the kind of concept question that I was alluding to today in class. Now, since you are allowed to use your calculator, the perhaps easiest way to do this would be just to use tables. Let me model that for you in case you've forgotten. So to start with, you're going to want to go to y equals, and you're just going to type in this whole expression inside the limit. Make sure that you use an extra set of parentheses around the entire numerator so that it's all getting divided. This is what it looks like. Notice that I put in x's instead of h, and that's just because that's where we're evaluating the limit. In fact, this should have said h, which is 0. I apologize about that. Now, to evaluate the limit, I'm going to go to table set, and I'm going to ensure that my table is starting at 0, because that's where I'm evaluating the limit. So there's my 0, and then you want your step to be a small number. And now I can go to the actual table, which was second table, and we notice that there's an error at the value 0, but when I look on either side, the two sides seem to be approaching kind of a similar number. They're both somewhere around 1.32, 1.34. Now, if this isn't really close enough, if you're not confident saying, oh, aha, I found the limit on both sides, one thing you could do is you could go back to the table, set up, and you could make this increment smaller, because the smaller this is, the smaller the steps are that we look at, like the steps for the secant lines, which means your limit should get closer. So I'm going to try 0, 0, 1 instead. And then I go back to my table, and you have to make sure that you're looking at 0, so either you're going to have to scroll up until you find 0, or down until you find 0, or you can just go back and reset the table to be at 0. And now I'm a little more confident about this. Sure, they're still a little bit different, but now it really does look like they're both kind of honing in on 1.333. And if you think about your answer choices, 1.33, where's the question here? 1.33 is the same thing as 4 divided by 3, and that's why the answer was B. Question number 6 is fantastic. Also possibly frustrating, but this is definitely a concept question. And in any concept question, you want to start by really believing in what you know. You know a lot about this problem. Maybe not how to get the answer, but you know a lot. And actually, if you're willing to trust that, you will get the answer. So the first thing I am going to do is I'm just reading this and interpreting. If f of x equals 3x squared minus x, okay, there's some function, and g of x equals f inverse of x. Oh, okay, so they're telling me that g of x is the inverse function of f of x. Then g prime of 10. Prime means take the derivative, and that means at 10, so 10 must be an x value where we're trying to take the derivative. Could be, and then they want a number answer. These numbers are supposed to represent the slope of the inverse function when x equals 10. So when I free associate, here's a couple things I know. G of x is the inverse function. In other words, its x and y values are switched from f. One thing you could do here that I chose not to is you could have actually tried to find the inverse function by switching x and y. You might have gotten stuck in the algebra, but that would be a possibility. I think the conceptual way is quicker, but it requires that you can follow a couple steps. Let's see how they sound to you. We already talked about the first point. The second point that I made was that 10 is the x value of a point on g of x, which means it must be a y value of f of x, and that's because they're flipped. So I'm imagining there's some point that has a 10 that's a y value for f of x. And I don't know what the x value is, but I could solve for that. So I took the f of x equation and I set it equal to 10. And then I came down here and I solved, actually, to figure out what x would have to be. And I came up with two possibilities. It was a quadratic equation, so I factored it, and then I got my two solutions. And that to me means that f of x has 2 points with a y value of 10. And since g of x is the inverse function, either one of those points could be the kind of corresponding point on g of x. And so this is where that last connection has to be made. The derivative of the inverse function at a certain point is the reciprocal of the derivative of the normal function at the corresponding point, as in the point with the x and the y's that are flipped. Right, so we're talking about this point, which is on f of x, because that's how I solved it. And in fact, we're talking about two possibilities. Either the x value is this, or it's this. And since I know the x values, I can find the derivative of f because I have an equation for it. F is this equation. Taking its derivative is really easy. It's just 6x minus 1. So I can find the derivative of f at these 2 points, and just by plugging in the x values. So the derivative of this point I got to be negative 11. I'm sorry I screwed up the negatives briefly here, but it does work out to be negative 11. And the derivative of the point where x equals 2 turns out to be positive 11. So I am imagining some function, f. Who knows what it looks like, but it's got 2 points where where the y values are 10. Maybe like that. And then when I create the inverse function, it flips over, and there are 2 points on the inverse function. Now, what we know about inverse functions is that the tangent line of this inverse function has the reciprocal slope from the original. Remember we drew that line and flipped them over and looked at their slopes in class? So if I really trust myself, I understand that there's 2 points on the original graph that have a y value of 10, which would correspond to 2 points on the g of x graph with x values of 10. And their slopes should be the reciprocal of the slopes on f. So the reciprocal of negative 11 is negative 1 over 11. And the reciprocal of 11 is 1 over 11, which is why the answer here was E. Question 7 I eliminated because you don't know how to do it. I apologize about that. It gave me some extra space to work. And question 8 is beautiful. This is kind of a definition one. Maybe it seems like a conceptual thing to you. To me, it's just definitions, but, you know, potato, potato. If the function f of x is differentiable, one thing that you know for sure is that it has to be continuous at every point, and it has to be different. It has to have the same slope on both sides of every point. Now, I'm not really interested in every point. I'm really just worried about the point where the piecewise function has its break. The 2 sections sometimes come together in a way that's not differentiable. So I know that it has to be smooth even at that point where x equals 1. So I'm going to use that fact. Because I know it has to be continuous, I know that the right-hand limit has to equal the actual y value, has to equal the left-hand limit. And these 3 things are things that I can calculate algebraically. I take the right-hand limit by looking at the right-hand side piece. X is greater than 1 represents the right side of the graph. Remember, visualize it. It's this stuff over here. So if I take the limit as x approaches 1 of this term, I would find the y value that the graph is approaching when I come from the right. And taking that limit is easy. You just plug in 1. And then you get a limit in terms of b, which is still a variable, but that's okay. It has to equal this, whatever b is. By the same logic, the limit on the left, we follow the left-hand side equation, and we take the limit, and we end up with a minus 6. Incidentally, if you were wondering, the actual y value of the function is the same as the left-hand limit in this case, and that's because of the less than or equal to sign right here. So I just plugged straight into that equation, which is kind of the same thing as taking the limit. All of this is to say, whatever a and b are, they must satisfy this equation. Now I came over here and talked about slopes. Just like it had to be continuous, it has to have the same slope on both sides of x equals 1, and the slope near x equals 1 is really the derivative at that point. So I took the derivative of both sides, and I just used the normal derivative rules with these equations. When I took the derivative and plugged in 1, I got a second equation, And that allowed me to solve a system, which allowed me to figure out that A is negative 14.